So all of our light reactions are taking place in the thylakoid. So we've got a cross section of a thylakoid, and it's showing inside of this membrane. And we're starting with the first process. We need light. For the light-dependent reaction, meaning you need sunlight for this to happen. The very first thing that the sunlight does is it provides energy to split water molecules. This is photolysis. Okay, when we split two water molecules, we end up with an oxygen, which is just a byproduct. Okay, this is released out of the cell, and it goes out into the atmosphere. We also get some hydrogen ions, and we get an electron. When the electron is struck by this light, it gets excited, and it goes up to a higher energy level. So now this electron is raised to a higher energy level. The first set of the photosystems is photosystem 2, so the order's reversed here. The electron gets excited, and then you can imagine the photosystem as if it were a set of stairs. When the electron tumbles down these stairs, it's providing energy that's needed to make ATP. So at this point, it's full of a lot of potential energy. When it starts moving through the photosystem, it's releasing this energy. An important product of the light reactions is ATP. This is an endothermic reaction, so this is where we're getting the energy from photosystem 2. In order to react ADP, adenosine diphosphate, with an extra phosphate group to make ATP, which has a lot of stored energy. These hydrogen ions that we got from photolysis, they start to accumulate in the cell here. And the purpose of that is now we've got a chemical gradient between the inside and outside of the cell. I've got a higher concentration inside than outside. When these ions move through this channel, which is called ATP synthase, this is what's generating the ATP. So we're getting energy from photosystem 2 and then energy from the movement of these hydrogen ions. The next step, so here's our electron. It's tumbled down the stairs, now it's at the bottom. Okay, this electron then gets excited again, so the light strikes it again, and now it jumps up to a higher energy level in photosystem 1. Once it's in photosystem 1, you can imagine that there's another set of stairs that it's going to be tumbling down here. And the final electron acceptor, so there's a chemical that's waiting at the bottom of these stairs, waiting for this electron. And that chemical is your NADP+. This is the final electron acceptor. Okay, so when we add an electron as well as a hydrogen, we end up with this product, NADPH. So the whole point of this light reaction is that we need ATP, which we made here, and NADPH, which we made in photosystem 1. These need to move on to the next phase in photosynthesis, which is the light independent reactions.